The last thing we need to do related to limiting reactants is be able to calculate what's called a percent yield. So let's go back to our bicycle example. We have all of the ingredients. We've made as many bicycles as we could. We figured out how many extra bicycles were left over. But what if we're not a perfect bicycle builder? What if we didn't build all 4 bicycles because we made a mistake along the way and had to toss one of them? What is the percentage yield if you were only able to make 3 bicycles? So think about this. You should have been able to make 4 bicycles, but you only were able to make 3. This is something that happens in chemical reactions all the time. You don't get that perfect amount of product. Either it doesn't react completely, or you lose some of your product along the way, or you didn't combine things in the ratios that you thought you did. There's always something that's going to hinder your reaction. You never are going to get 100% of what you expected to get. So when we do that, we calculate what's called a percent yield. So we were only able to make 3 bicycles, even though when we made our calculations, we calculated that we should have made 4 bicycles. This 4 bicycles is called our theoretical yield. This is theoretically how many bicycles you should have made. We get this by doing a lot of math. We mathematically calculate how many bicycles we should be able to make given all the amounts of the different ingredients. The 3 bicycles is our actual yield. And usually you get an actual yield less than your theoretical yield, but things can happen. You can end up with 100%, over 100% yield just because of incorrect measurements or contamination or whatever. But your actual yield is what you get experimentally. This is your experimental yield. When you're doing a chemical reaction and you weigh your product, this is what you actually get. So how we calculate our percent yield is we take our actual yield divided by our theoretical yield. That ratio, we are going to turn that into a percentage. So we take that and multiply by 100%, and that is going to give us our percent yield. So let's calculate the percent yield for our bicycle building. Okay, we created 3 bicycles. That is our actual yield. We should have created 4. Mathematics would tell us, and our calculations would tell us, we could have created a maximum of 4 bicycles with the ingredients that we had. That is our theoretical yield. So 4 bicycles at the bottom. We're going to multiply by 100%, and then we get 75%. So our percent yield is 75%. Now let's go and do this in terms of our chemistry problem. So we have in our laboratory, we were only able to make 7.5 grams of water just because of conditions or ingredients or different things that can take place. Different sources of error happen when we do chemical reactions, when we perform experiments. So we were only able to make 7.5 grams of water. Now, if you look back to the previous videos, you'll see that our theoretical yield should have been 9.0 grams of water. This is how much we calculated that we would be able to make with the amounts of ingredients that we had. Now, we only actually were able to make 7.5 grams of H2O. We take our actual yield, 7.5 grams of H2O, divided by our theoretical yield, or what we calculated, which is 9.0 grams of H2O. We multiply by 100%, and we get our percent yield. So if I do this on a calculator, I get 83%. And that is my percent yield for this reaction. Now, when you're doing these problems, make sure that you think about it in terms of something simple like your bicycles. How do we solve the bicycle problems? What procedures did we use? Use those same procedures in chemistry-related problems. Also, I would highly recommend labeling everything. Label what you're given. Label what you need. Label your A's and B's so you can follow the steps of the stoichiometry and you don't get confused. There's a lot going on here, and you're having to combine different ideas from the entire semester of chemistry. So it's easy to make little tiny mistakes. And if you keep your work clear and you label as much as you can, you'll reduce the likelihood that you'll make those mistakes.